So let's look at the equilibrium constant over here. So what exactly is the equilibrium constant? The equilibrium constant is just basically, in short, the relationship between the products and reactants in a reversible reaction. Remember that, a reversible reaction, right? And it's usually represented by, in your textbooks, usually by Kc or Keq. That kind of depends on your textbook or the format that your teacher is teaching, right? So if you have a reversible reaction, it would look like this, right? You would have A plus B, you can either go forward or in the reverse, right? Represented by these arrows over here, right? And these little letters here, these small letters, I'd say, lowercase, they represent the number of moles, right? They represent number of moles of the product or reactant, right? And that's going to be especially useful when we look at the formula for this, right? Because the equilibrium constant is equal to products or reactants in short, but the actual formula looks something like this in the red over here. Your equilibrium constant would equal your capital C, which is, let's say, one of your products, to the power, right? It's brought to the power to the number of moles that it has. Same with if you have another product, it would go up here too, and it would as well be to the power of moles it has. And usually you're given the concentrations for many type of problems, or the problems we're looking at today. We're going to be given the concentrations for C, D, A, and B, and we're just going to be trying to calculate Kc, right? Straightforward. We're given all the concentrations needed to calculate Kc. All right. So let's look at a problem. All right. So for our first problem here, we're given a reaction in equilibrium at some temperature T, right? All right, so we know this is reversible. We can kind of see this over here, so it's reversible. All right, so we're cool. So and it's asking us to find what is our equilibrium constant. So let's get to it. So we know that our equilibrium constant Kc is equal to your products, right? Products over your reactants, right? All right, so let's get to it. So your Kc should equal, in this case, what are my products here? My product here is right here. That's my only product. So it would be SO3 gas, remember, and it would be to the power of the number of moles it has in front of it, so it's 2, like so. Right, and all over the reactants. And what are my reactants in this case? We have 2 reactants, so it would be SO2 gas, right? Sorry, that 3 looks off. SO2 gas to the power of 2, as why? It is 2 moles in front of it, just like this one over here, 2 moles in front of that. Now the final reactant to look at is our oxygen here. So our oxygen, I'll write it like this, just O2 on its own. O2 gas, like so. All right, so now let's get to calculating because we're given our concentrations here. Let's just plug and chug. Make a little border here, like so. All right. So this would be equal to, what's my SO3? SO3 is 1.1 moles, and we're squaring it over here, SO2, which is 0.90 squared, moles squared, and O2 would be 0.35 moles on its own, like that. And I'm just going to calculate this. Okay, so 1.1 squared, what is that? That is 1.21, so it'd be 1.21 moles over 0.90 squared, then multiply that by 0.35, and we would get 0.2835 moles. Now we do division here, and we can see that it is 1.21 divided by 0.2835. We get 4.26, or we can round up because it's 8, so we do 4.27. But our Kc doesn't really have any values like moles or anything. You just leave it as 4.27. So that's our equilibrium constant is 4.27. You can box that. You can write a sentence here saying, oh, the equilibrium constant is 4.27, but I think this is enough for that. This problem, I want you guys to try it on your own first, all right? So pause the video and try it on your own. All right, so I hope you guys try it on your own. Let's get to solving this. So the first step in this case would be to actually identify what our Kc is equal to. Our Kc in this case equal to your products over your reactants, right? That's something that you should know. The next thing I want to do is I want to write out what it would basically equal to. And my Kc would be equal to my product. My only product is this. So it would be NCl3 gas to the power of 2. As remember, there's 2 moles in front of it. So it would be to the power of 2. And it would be all over values of my reactants over here. So first thing, my N2, the order doesn't matter here, guys. Just this is multiplication to the power of 1, just 1. And then we would have Cl2 gas. But for this one, it's 3, so we would have to put it to the power of 3 here. All right. So let's get solving this. So let's look at our concentrations given over here. So our NCl3 gas is 0.50, so it would be 0.50 moles squared over your N2 gas, which is 0.15 moles to the power of 1, right? And then we would have Cl2 gas, which is 0.25 moles cubed. Now, if you do the calculations here, which is 0.50 moles squared, right? And then you would want to multiply the bottom, right? And then you divide what you got from the top divided by the total of the bottom. And if you did that properly, it would basically be 0.25 over 0.00234,375, and you would basically get the answer was 106.6 with the 6 just repeating. All right. So that's basically how you can basically calculate the equilibrium constant, right? I hope this video helped.